Hey everyone, this is Todd Millar at Millars Mills. Today I want to talk to you about our brand new Millars Mill pilot model. Of course, it's the end of the day, so I'm actually drinking a beer while we're doing this, which I'm sure most of my viewers will understand. It won't hold against me. Obviously a beer that I brewed myself. Today I want to talk to you about the construction, because we've been building mills for the last 10 years. When we built the first one, it was a very similar construction to most mills that are on the market. And this is the way almost all mills are built. In fact, I don't know anybody that's doing anything different. This is one of our older models, actually the B3, the model right before this new one. And the basic construction of most mills are about the same. If you can see this, basically you've got a few plates. You've got a plate here, you've got a plate here, and a plate here, and a plate here, and they're bolted together. Very simple construction. As far as manufacturing, very inexpensive to manufacture. It does have some drawbacks. And we've seen those drawbacks over the many years that we actually produce these mills. The one big drawback is during a high usage, especially for a guy that's using it for a pilot system or is really serious about brewing, the actual bolted together units will kind of rack. It's not a very rigid frame. So we kind of rethought this whole thing. We thought, you know, this is obviously industry standard. Everybody's doing the same construction. We want to take it to the next level. What we actually ended up doing is starting out with a solid piece of billet aluminum. And we did it in two pieces, but in a different way. Rather than plates on the ends, we found that if we did it as a solid shape, there's no racking. It's actually a solid piece or a solid mass of aluminum. And then we actually sandwich it together. It's clamshell. And we actually capture the rollers and the bearings within that. But this is superior. This is actually, we believe this will never ever fail. I mean, I can't twist it or even make it move one bit because it is solid aluminum. Now within that, we actually put a much larger bearing. Previous bearings that we used to use on these mills were a pretty modest bearing. I mean, not a bad one, a smaller bearing on the output shaft. And what we found is most of the pressure on the mills are getting, all the pressure, in fact, is getting force on the actual shaft. So you've got a shaft that's getting a lot of torque this way. And what happens is the bearing itself starts to wear prematurely. So we recognize that. We saw some of them coming back from people that use them for pilot systems and really put a lot of abuse on them. In a home environment, probably not going to happen as much. We felt like, hey, let's take it to the next level. So we did two things. First thing we did is we changed the shaft diameter. Typically, you're going to find on most mills, they use a 3/8 shaft or something in that, if it's an import model, something in that neighborhood. The problem with that is again, there's a lot of pressure being put on the shaft with a pulley. Most guys will motorize or put a big giant drill on it. And what happens is that actual shaft eventually will warp or bend or flex. So we did two things. We did the larger bearing on the end. It's a full 1-inch bearing to apply, so a lot more pressure can apply to it, and it will still run very smooth and not, we oversized the bearing per se is what we did. Second is we put a 1/2-inch shaft, and we made it out of solid stainless. We used to use, and this is what most people use, is just a mild steel, which works great. And then the third thing we did is we put a triple flute. And if you can look at the mill a little closer, you'll see there's a triple flute. The reason why I put a triple flute on that is drills. Most guys are chucking their mill up with a drill. And when you chuck it up with a drill, there tends to be some slippage, especially if you have an older drill or a chuck that's been used well. Inside the chuck can get kind of smooth. So you'll find even on the one I've got here, I've got a couple older models, the shaft is a little smooth. You can see where my chuck even spun a little bit. So rather than just looking at it as a shaft for a hand crank, we went to a triple flute. That also helps you when you're putting a pulley on it, which is nice. So that was a big improvement for us. We felt like it was needed and needed to be addressed. A couple other things that we did, we felt was really big improvements, is the rails. So we started out, our first unit, we used a pretty standard piece of aluminum for the rails. Some guys, even the cheaper imported models, they use just a piece of wood. Which I didn't really like because you couldn't see, when you set this on top of a bucket with a piece of wood, you couldn't see the grain as if your bucket was filling up. So I felt like exposing it so I can actually see inside there. This was a big improvement, but it slid around a lot. So we had to put foam on it, try to keep a good hold of it, and sometimes it would fall off the bucket. So this new idea was an actual piece of billet aluminum, both sides as well. But what we did is we made it actually lock onto the bucket. This, in fact, will lock onto a round bucket or provide a bucket that we provide with the unit. But I like this one better. It has a little bit more attributes. It looks better as well. But this solid billet aluminum, much stronger, much more positive, connections. So we don't have to worry about that coming off. Some of the other things we did, which I really liked, is I like the adjustment pins. The adjustment pins on these new mills, they actually have a travel that's not infinite. We used to make it infinite, and when you make it infinite, basically what happens is you can actually go around a full circle on the cam to adjust your width and your gap of your actual grind. You can sometimes bind it because you can actually get it so completely crazy it'll go sideways. So we put an adjustment in a little shaft in it so it locks. There's actually a travel that locks. So once you find your perfect, you of course lock down the adjustment knobs and you're good. Another thing that we did, what we really liked, is because a lot of guys were actually coming to us and they were saying, hey, I want a mill that can actually grind larger seeds. Most guys that distill corn, almonds, all kinds of crazy debris going through it. I've had the weirdest requests for the mills. Some guys even grind glass, believe it or not, which I wouldn't recommend. So what we did is we went to a 0.45. And what that is, it's almost a ½ inch. So the gap that we have, much larger gap. I can actually do, if you can see this on the film, you can actually see there's a huge gap. So that'll allow you to grind much larger debris, depending on what you're doing. I've ground some pretty strange things, even cocoa beans actually, that worked great. So the other thing that we did that I felt like it needed improvement, the hopper. A lot of guys are, they look at the hopper, they all look the same. They've got this kind of this wedge shape. And that's neat if you're just wanting this size hopper or this capacity. What I didn't like about the wedge shape is you had to do some math. It was kind of weird. Guys would take cardboard and do kind of crazy stuff or put sheet metal to try and extend it to make a larger hopper. If you're going into like a pilot system and you want to do a little bit more volume, it's a lot more math, brain game that you have to do to come up with a hopper that's larger. Not to mention it gets giant. Your hopper gets this way. So I felt that making a straight-sided hopper was a big improvement. What that does is that means I can actually attach straight flat products or flat material to my hopper to extend it. I just think it was much easier. Of course, and also a drop that's straight up and down is going to feed a little bit faster than an angle. So it's all gravity. Gravity straight down is much better. As it funnels into the bottom, of course, it slopes and goes into the actual grain mills. The other thing that we did is we felt that this mill is going to be put through punishment. We know it's going to be put through a lot of commercial use. We're not selling it as a commercial mill. I call it a pilot mill, and the reason why I call it a pilot mill is most guys that are buying these are, hopes and dreams down the road. They're going to start a brewery. My thought is let's build something that's rugged enough to really work out recipes and do a considerable amount of volume. So what we did is we actually anodized the actual aluminum. So we start out after it's CNC milled, very raw aluminum, very pretty, but not much protection. And even on a mill finish, if you were to buy plates of aluminum like on our old one, it has a mill finish, but there's no protection there. It's going to tarnish, it's going to actually corrode, especially with the caustics we use in brewing. So what I did is I came up with the same exact finish that Apple uses on their products. I'm a big Apple fan. The design of it, of course, it has kind of an Apple-esque look. But my idea was, let's put a hard anodization coating on the actual aluminum frame. And the reason is, obviously, it's going to get scratched, it's going to get bumped, it's going to look nice, it's going to definitely last longer, and it's going to keep it from corroding. The other thing we did is, instead of using aluminum, which is what everybody uses, we used it before. Aluminum's great, it's inexpensive, it's easy to work with. We went to a 304 stainless, and I didn't go with thin stainless. This is 22 gauge, and I've even gone as much as 20 gauge on different runs, but 20 and 22 gauge stainless steel, and that's rigid. I mean, this stuff is stout. And the reason why I did is, in a brewing environment, we're using a lot of stainless steel. Stainless steel is superb. It's the best. And I also We use a real high-grade rivet system to rivet it together. So it keeps it together. It's not gonna fail on you. The other thing that we did, and we kept with this, but we've changed our heat treatment a little bit better. We're now using it's a nitrogen quench heat treatment. This is a 400 series stainless roller. So we have actually the hardest rollers. Our rollers are Rockwelling is in the high 50s. I think I put on the website in the 40s, the high 40s. We've actually tested it. We've been in the high 50s. This is going to last much longer than any mild steel roller that's available on the market. Guys are going out there. I see a lot of information online on the imported ones especially. They say hardened rollers or heat treated. I would say check it out. If you know somebody that's got a Rockwell tester, test it. I think you'll be very surprised. They're calling them hardened. They're not hardened. That's been my experience. So ours is great. Ours is definitely going to last longer. You're going to get much longer use out of it. Again, this is a 400 series stainless. It's not rust proof. It's rust resistant. And this is something that I want to make sure that people hear about. I've had guys actually soak these in caustics or leave them really, really wet. You should never mill any grain that's wet. You should only mill grain that's dry or any material that's dry. These mills are not designed to mill, wet grain. It cracks me up though, because guys, I've seen them put away wet and they say, hey, I've got surface rust. Well, you're going to get surface rust because 400 series stainless is not rust proof, it's rust resistant. That is actually the only stainless steel that you can heat treat, and that's why we chose it. I would have done a 300 series, which would be much more rust resistant. I didn't do that because you cannot heat treat it. So that's why I use 400 series. But I mean, rust is not an issue. I mean, I can assure you that that is not an issue that we have. A couple other things we did is we improved the actual hand crank. What I did is I found that we used to use a mild steel with a black oxide, and it was kind of cold. It worked great. It isn't, and black oxide is not rust proof. In fact, it can rust. If you look at it sideways, it'll rust. And the handle itself was steel, made out of a steel. We went to a Delron handle, and that's a little smoother. I just like the design. It too is made out of a solid billet piece of aluminum, and it's also been anodized as well. So anything that's aluminum, which is the frame, the rails, the handle, that's all anodized aluminum. So it's going to hold up to any type of abuse that you throw at it. We're also packaging the unit. So when I package my unit, I put it in this bucket. So we had these buckets custom made for us. They're pretty unique buckets because they're kind of squarish design. And what we did is you can actually break the mill down and put it back in the bucket. We've got this very special foam. It's all die-cut foam that can go back into the actual bucket for storage. We provide a scoop, which is nice. I get some people like, I don't need the scoop, but it's not a big deal. It's not a huge cost for us, but it's an added value. It's kind of a neat package to put them all together. Our manual is pretty conclusive. It's going to tell you everything you need to know about the mill. You've got some really nice adjustment marks on the end of the actual mill. It's going to give you some reference points. A lot of people call me and ask me, and they say, or email me and say, what number should I be on? And this is something I'm going to answer right now. I want people to hear this. There is no set number for any specific grain. And the reason why it is, grains come from all over the world. You might have a farmer that's in a co-op among other farmers, and his grain kernel might be slightly bigger or slightly larger, or smaller. So what happens is, if I told you a set amount of setting on the mill, and you run it through your mill, you run grain through it, and you get either a low efficiency or you get a stuck mash, I'm going to be in trouble. So I don't recommend coming up with giving you a number. I don't recommend a number. So what you want to do is you want to actually go through the grain, go through the finished grain after you've milled it, and hold onto it with your hands and take a good look at it. It should be about 3-piece crack. That's what we like to see as brewers. The kernel itself should be broken into 3 separate pieces. Of course, you're going to have exceptions to that rule. You're going to have a few kernels of grain that they get past it, are a little smaller. Some are bigger, some might crack even more. But it's all about efficiency. It's all about cracking the grain. We're just trying to get into the center of the kernel of the grain to get the starches out of it, to make the conversion, to make the beer. So you're going to find that with whatever setting you want to check it, you're going to also find that you want to check it down the road. Once you get a setting you like, you get another bag of grain, you might want to check it periodically, make sure you're still getting a good efficiency. And here's the other thing. Some brewers have a really efficient, really nice beds inside their mash tuns. Some have very big holes, some have very small holes. If you don't mash in and mash out at the right temperature, as you know, you can have stuck mashes, and it has nothing to do with the size of the kernel of the grain. It has to do with temperature and time. So you want to just make sure that you use, you use it to your best ability. That's going to work best for you. And trial and error is unfortunately the only way you're going to figure it out. So some guys use the credit card. They'll put a credit card in there, adjust it to that, and say, hey, it's a credit card. That works. That gets you kind of in the ballpark. But just trial and error is the best method. I'd really like to thank you guys for checking me out. Hopefully you are a part of the Millars pilot project. Hopefully you buy one of our mills. We've got a lot of pride in it. We're 100% made in USA. We love the fact that we can actually employ US citizens here in the United States. We don't use import parts. Our unit is built to last. So there is no better mill in the market, and I can confidently tell you that. Each one that goes in each bucket, and we ship each one out, you're going to find there's great care to each mill, and you'll appreciate the quality. Thank you.